Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a seriously cool GitHub project, Dr. TVAM, an inverse rendering framework for tomographic volumetric additive manufacturing. Sounds intense, right? But trust me, it's fascinating.
Inverse rendering? Tomographic additive manufacturing? I'm intrigued, but I need a little more context. What's the big picture here?
Okay, so imagine you want to 3D print something really complex, something with intricate internal structures. Traditional methods struggle. Dr. TVAM uses a clever trick. It works backward. Instead of figuring out how to build the object directly, it uses inverse rendering to determine the optimal light patterns needed to create the desired 3D structure, layer by layer, using light-based 3D printing.
Whoa, so it's like reverse engineering the printing process? Instead of saying, here's the design, make it, it's saying, here's the result, what's the best way to get there?
Exactly. And it's based on the Mitsuba renderer, which is a big deal in the rendering world. It uses physically based differentiable rendering, which means it can calculate how light interacts with materials incredibly accurately, and then use that information to optimize the light patterns. This allows for things like scattering printing media, arbitrary vial shapes, and even custom projector motions, all within the same framework.
Scattering printing media? What does that even mean?
Think about how light scatters in fog or milk. Dr. TVAM can handle materials where light doesn't just travel in straight lines, making it much more versatile than traditional methods. It's a game changer for creating complex multi-material objects. The improved discretization scheme is also pretty neat. It allows for more precise control over the final shape.
I see. So this isn't just some theoretical project, it's actually usable? How do I get started?
It's surprisingly straightforward. You can install it with a simple --pip install Dr. TVAM. They even have a command line tool for basic optimizations. Dr. TVAM path /config.json. The documentation on Read the Docs is excellent, with Jupyter notebooks to guide you through more advanced usage. There's even a teaser video on YouTube.
Awesome. But you mentioned a non-commercial license. What's the catch?
Yeah, that's a bit of a bummer. It's open source, but it's for non-commercial use only. Check the license file for the specifics. Still, the research behind it is incredibly impressive, and the code is freely available for educational and research purposes. It's a significant contribution to the field of additive manufacturing.
Definitely. This is a really exciting development. It seems like Dr. TVAM could revolutionize how we approach complex 3D printing. The authors, by the way, are from EPFL, which is a top-tier university. That speaks volumes about the quality of the work.
Absolutely. And don't forget to check out their SIGGRAPH Asia 2024 paper for the full details. They even have a workshop planned for spring 2025. You can sign up on their GitHub page. This is one project to keep an eye on, folks. Thanks for tuning in to Tech Bytes and News. We'll catch you next time.
Bye-bye.